Okay, good morning. So let us start the lesson. So here we want to continue with algebra, the topic of equations. We introduce what is the meaning of an equation in algebra. And then we want to discuss about different algebraic equations and then try to see how we can solve them systematically. So if you remember, I told you that it is not possible to solve all equations, but in this course, all the equations that we are facing are of those types that are solvable. And we start with the simplest one, and the good news is that in Math 1C, that is only the simplest one that matters. Okay, so what we do here, we want to have the solution of this equation. The general form is this: ax and then plus b equals to 0. A is a real number, but it is not equal to 0, because if a is 0, nothing is left to find, yes? And b can be any number that you like. So b belongs to the set of real numbers. B is any number that you like. This symbol means belongs to, and this symbol means the set of real numbers. So this means that b is any number that you like. A is also any number that you like except 0, because clearly if a is 0, there is no unknown left for you to find. Okay, if you want to solve this equation, there is a systematic approach to find all possible solutions to this equation. So there are two properties that are involved. I want you to know. Of course you know, but let me just remind you. We know that if a number A is equal to a number B, I am allowed to add one number to both sides, yes? And keep the equality valid. What do I mean by that? If you want to, you can write A plus C is also equals to B plus C. So if I give you that A and B are equal numbers, you can, if you want to add one number C to both sides, still the equality holds, yes? Yes, it has to be the same, because otherwise I told you that in algebra, when I am using the same, yeah, please keep quiet. When I write C in one problem, I always mean they are the same. So this C on the left has to be equal to the C on the right. Okay, so if A is equal to B, A plus C is B plus C. If A is equal to B, I can conclude that A minus C is also equal to B minus C. And moreover, if A is equal to B, I can conclude that A times C is equal to B times D. And finally, if A is equal to B, I can conclude that A divided by C is also equal to B divided by C, but there is some exception here, and that is C shouldn't be 0, because division by 0 is not allowed. So this needs that C is not equal to 0. So these are something that you really know. Yes? Yes, thank you very much. Thank you. Okay, so if you divide A by C is equal to B by C, here the exception is that C cannot be 0. But these are understandable. If I give you two quantities that are equal, it is clear that if I add the same number to the left and to the right, the new values are also equal. The same thing for subtraction, multiplication, and division. For the division, I have to be careful that this number is not 0. That's it. So this is the idea how to solve the problem. By the way, these arrows are double-sided. So it means that if I give you this, if you want, you can come back and conclude this, yes? If I give you this, you can go back and conclude this. Here, if you want to go in the backward direction, C shouldn't be equal to 0 if you want to go from here to here, because you are dividing by C this time. And this is also valid. Let me write it in this way. Okay. So now let me start with a very simple question. So for example, I ask you solve. Remember, this is the way that I ask. Solve the following equations. So what do I mean by solve? I mean find all possible. I am emphasizing on the word all. The good news is that for these equations, by the way, these equations are called first degree equations with one unknown. There is only one unknown that you are supposed to find. Why it is called first degree? Because the highest power of the unknown is 1. Yes, we are always studying these kinds of equations in this course. So solve the following equations. Let me start with a very, very simple one that you really know how to solve it. For example, I would say 2x plus 3 is equal to 9. So I want to find the value of x. Even if you can guess, guessing is not enough. You have to do it in a proper way. Of course, I want to follow these rules, but I want to teach you to do it faster later. I want you first understand why these rules are important in solving that equation. Then after that, I will teach you how to do it a little bit faster. Yes? No, I don't. This is very simple, of course. So what should I do first? I use this rule now. You are telling me that this number is supposed to be equal to this number. So this means that I am allowed to conclude this. Yes. So you be careful here. So this is my goal. I am supposed to find x. I will be able to find x if I make x alone on the left-hand side. So that is my strategy. I want to get rid of all these numbers and coefficients so that x becomes alone. So the first thing that I can get rid of is to get rid of this 3. How? By adding, yes?
Does it matter in which order you do it?
Yeah, let me finish this and then you start listening. Okay. This is so simple. I'm just explaining because later I understand you will start asking questions. Okay. So what do you mean by which order here?
Like if the equation on the left hand side, or like the whatever the hell you call it, if there's like 2x plus 3 and then multiply by some other number and then.
No, we will reach to that. I don't know why you jumped immediately to that example. Okay. Okay, so when we add minus 3 to both sides, we get this one. Why this is good? Because I told you, you need to have a strategy. This problem is so simple that even if I don't teach it, you can solve it. But me as a teacher, when I start teaching, I have to teach you in a way that you can solve harder problems. For solving this problem, you don't need a teacher, yes? So, but the explanations that I am giving, this is sometimes the wrong impression. People think that, okay, why Babak is explaining this problem so simple, so much? Because the rules are important. So if you do not have an organized brain when it comes to mathematics, you will not be able to solve harder problems. And that is the goal. When you are here, I'm teaching you in a way that you can solve harder problems. Okay, so what we want to do, so this is the strategy. If someone asks you what is the general strategy of solving equations, there is one sentence to it. We want to make x alone. Okay, so for making x alone, I have to get rid of this factor of 2 and I have to get rid of this factor of this coefficient, this constant number 3. So I start from this one because this 2 is bounded to my variable. So let me get rid of this 3 first. How can I get rid of this 3? I can use this rule. If two quantities are the same, I can subtract the same number from both sides and still I know that the equality is true. So I start adding that. So what happens here? These two are gone. So what is left is 2x. What is left on the other side is 6. Okay, and then I want to get rid of 2. Which one of these is suitable to get rid of 2? You can use this one or that one. It depends to your taste. If you use this one, you have to multiply by 1/2. Yes. If you want to use this one, you have to divide by 2. Both of them are possible. So let me just do both of them. Some people are more comfortable doing this. if you write that, some people prefer to multiply both sides by 1/2. And then 1/2 and this 2 will be cancelled. It becomes 1 times x. This becomes 3. So that is your answer that you are looking for. Or some people prefer to divide. I myself prefer to divide, unless this is a fraction, yes? So what I do, I will divide both sides by 2. And then this becomes 1x, which is just simply x, and that becomes 3. So you see that the answers are the same, doesn't matter which way you choose. So this is the general strategy to tackle this problem, yes? But it sometimes becomes boring if you want to write this step over and over again. So what happens if you momentarily do not look in the middle because this is gone? It means that nothing is left here. Then you have 9 and minus 3 here. So what does it mean? It means that it seems that I have moved 3 from the left to the right. But what I have done, I have changed the positive sign to negative sign. So this is in general possible. So you can do what? You can move these numbers around from one side to the other side. But in these movements, you have to be sure that you are changing the sign. If the sign is positive, you change it to negative. If it is negative, you change it to positive. Okay? So this is the way we do it. But let me just, for the time being, start solving some problems of this type. Writing all the details. So for example, I can have 5x minus 2 is equal to 2x plus 7. So that number was easy to guess, but might be this is not that easy to guess, even though that's also not hard. You might be able to guess. But even if you are able to guess and guess it correctly, that is not acceptable. You have to write it in a proper way. So here, the main difference between this problem and the first example is that I have an unknown on the left, an unknown on the right. So I should have one unknown on one side with coefficient 1 alone, and every other thing on to the other side. So this motivates me. For example, we can do it in some steps. For example, I move this 2x from the right to the left. Okay, so I have 5x is already there. I 2x move it to the left. It becomes minus 2x. And then I have 7 on the right, and I move minus 2 to the other side. It becomes positive 2. So is this a step clear? Yes, so you just start moving things around. I usually prefer to put in unknowns to the left, but that's up to you. And then I move every number to the right. In the movements, you have to be careful. If it is positive, when you move it to the other side, it becomes negative. If it is negative, when you move it to the other side, it becomes positive. Is it clear why it is the same? Because why this is so? Because if I wanted to do it in 2 steps, I have to add minus 2x to both sides. That minus 2x will cancel this one, then minus 2x will be left here. If I want to get rid of 2, I have to add 2 to both sides. This becomes 0, that becomes plus 2. Okay, then 5x minus 2x is what? 3x, and 7 plus 2 is 9. And then I divide by 3, yes? So then it becomes x equals to 3 again. So if someone asks you what is the role of this number, what is the answer? I want you to understand when people say that, what did you find? How do you answer them?
We found x is equal to 3.
So what's the meaning?
That we saw. Yes.
No, what is the meaning?
Shit. Good question.
So you're just changing your tone in answering the question. You said that this I can read x is equal to 3. What is the meaning?
The variable x has the value 3.
No.
What the hell?
Yes? Close, but not exactly. So this is why I'm saying, this is why might be you don't learn mathematics. Because this you don't care. What is the meaning of x equals to 3? So what I have done?
You proved that the equation is true.
No?
No.
Yes?
You proved that that the equation can work if the value if x is equal to 3.
Okay, work is not a good word in mathematics.
Like
I want you to pay attention. Exactly this is why sometimes mathematics becomes hard for you, because you don't care about the details. So what do we mean by x is equal to 3? So how is that possible you don't know?
no idea. We were never taught this.
No, I taught you last time. I told you what is the meaning of a solution. Solution, you know that if I have some pills and I put it here, that's also in chemistry called solution. Yes? So why solution in mathematics is different? Because there is a definition for the solution. You need to train your brains to respect these simple things.
X, but I don't know what else there is.
No, how is that possible? You solve for x. No, there is one explanation I want you to understand.
That it's not the
X, 3 is the only value that if I replace for x, the left-hand side becomes equal to the right-hand side. Nothing else. You can choose your sentences, of course, but this is the meaning of the solution. So it means that by this method, you are able to show me there is one number that makes the left-hand side exactly equal to the right-hand side. And that number, we found it, and that is 3. So when I say what is the meaning of the solution, you need to tell me a solution is a number so that if x in the equation is replaced with that number, the left-hand side becomes equal to the right-hand side. So if you don't understand, of course you can solve the equations, and that is the bad thing about mathematics education, because people can solve without exactly understanding what they are doing. Okay, so I want you to understand that you have to pay attention to this. Okay, so let us solve some more problems. So we can actually extend the problem. Let me write another one for you here. So 4 times y minus 1 plus 5 times y plus 2 is equal to 3 times y minus 8. Okay, so now we want to solve this equation. Okay, so how should I solve this equation? First of all, you see, I have asked a question up there, solve the following equation, so it means that this is an equation, but of course you can see the name of the variable is y rather than being x, it doesn't matter. And you see that this is hard to guess now. So what we are doing here is actually a systematic way to reach to the solution, yes? Okay, so we want to solve that one. So you see that this is an equation, and I want to find the value for y, so that if I replace y on the left with that value, and I do the same thing with the right-hand side, the numbers become equal. But it is not clear, I hope that you agree with me, it is not that simple to guess that number. So what we are doing is really a good job, because we are doing a systematic way, we are following a systematic procedure to be able to find the unknown value. Okay, so what should I do first? The strategy is clear again. There is one single strategy, you have to follow that. And that is making the unknown alone on one side. I myself usually prefer to have unknown on the left, but that is subjective. Usually we do like that. Okay, but if I want to make y alone, there is something in front of me that I have to do it first. What can I do? I have to expand this, yes, because I want to get rid of all pairs of brackets. So I multiply this in by the algebra you learned so far. 4y minus 4, and then 5 plus 5y plus 10. On the right hand side, I have 3y minus 24. This is the first step. The second step is to put all unknowns on one side. Okay, of course I can simplify a little bit. It is always better to simplify and then continue. So can I simplify something on the left? Yes, because 4y and 5y are similar, minus 4 and plus 10 are also similar, so I will add them, it becomes 9y, minus 4 plus 10 is positive 6, and then I have 3y minus 24. Now, what I will do, this includes the unknown. My strategy is to move it to the other side. This doesn't include any unknown, so I will move it to the other side. But this 9y is already there. I move 3y to the left, it becomes negative because it is positive here. This is the only thing that you need to remember. And this minus 24 is already there. I move 6 to the other side, it becomes negative 6. And then you simplify. 9 minus 3 is 6y. On the right hand side, minus 24 minus 6 is minus 30. And then I want to make y alone, so I divide everything by 6. And then 6y divided by 6 is just simply y. And on the right hand side, it is minus 5. So this is the value. Y equals to minus 5. Again, let us repeat this. What is the meaning of minus 5? It means it is the only number. So that if I replace the y with that on the left and y on the right with that, the numbers become equal. Yes? If you are certain about your calculations, you really don't need to check it out. But it's actually, I mean, myself, I really hate to check the answer is right unless I'm not sure. Okay, if I'm sure that I have done my calculations right, I really don't need to check it out. But if you want to check it, there is one way to check it out. And then calculate the left-hand side and the right-hand side for the number that you found. Okay, so let us calculate the right-hand side, which is simpler in this case. What is the right-hand side? Instead of y, I put minus 5. So what happens? It becomes 3 minus 5 minus 8, which is minus 13 times 3 minus 39. And here I put minus 5 there, so it becomes 4 minus 5 minus 1 plus 5 minus 5 plus 2, and I calculate this. So this is minus 6 times 2 times 4 is minus 24, and it's minus 3 minus 15. And if you minus 24 minus 15 is minus 39. And you see that these numbers are equal. So this means that don't look for any other numbers. There is only one number with that possibility, and that is minus 5. And we already found that. So this means the solution of this problem. Yes? Any questions? Okay, so let us try to solve some more problems. Okay, that's it. That's the lesson actually for today. There are some tricks I want to teach you how to solve different equations. Okay, let me give you this. What is your opinion about this equation? So for example, 1 over 2 x plus 2/3 is equal to 3 over 4. We want to solve this equation. Okay, so this is not a new lesson, but the numbers involved are not integers, they are fractions. Okay, I want to teach you that you can follow the same method without doing a different thing, but it is not that efficient, especially if you have bigger equations. What do I mean by that? So again, my strategy is to make x alone, okay? So what I do, I will keep it on the left, and then I move this number to the other side. So it becomes 3 over 4, it's already there. I move this to the other side, it is positive, it becomes negative. And then you see that what happens, I have to work with fractions. The common denominator is 12, and so I have to rescale it by 3, it becomes 9. The common denominator, as I told you, is 12, but this time I have to rescale it by 4, so this becomes 8. and then it becomes 1 over 2x is equal to 1 over 12. Yes? And then because I want to make x alone, what do? I multiply by 2 or by divide by 1/2. Both of them will work. I want you to understand these are the differences. These are subjective matters, but we want to find the fastest way. If you divide, that also works. But here it's better to multiply, yes? If I multiply by 2, what happens? This becomes x. This becomes 1 over 6. That's the answer. This is one way. Another way is to decide to divide. That's also possible. But you need to divide by what? You want to get rid of 1/2. Let me write it here for you. So instead of multiplying by 2, which was much easier for us, you might decide to divide. When you divide by 1/2, and you have to divide by 1/2 here. When you divide this 1/2 and 1/2 are gone, you reach to your goal, you made x alone. But here you have to calculate things, yes? 1 over 2, do you remember what I told you about these kinds of fractions when we were doing arithmetic? So if you want to divide a over b over c over d, you need to multiply these two that are far away from each other and then multiply these two that are close to each other, yes? So this becomes 2 times 1 in the numerator, 12 times this one. But this becomes simple and this becomes 1 over 6. You see that you get the same answer back, but which one was preferable here? Multiplication, okay? So sometimes you have to multiply. But even the best thing, if I want to do it, I will not do it like this. I would get rid of fractions from the first step. How? This is important. This is an important lesson. You might say that, okay, why I need to bother to learn this trick when I can solve the problem using the previous trick? If you don't care about these things, then if the problem is simple, you can manage it. But if the problem is hard, then it becomes really hard if you just follow just these rules. So here, my preference is to get rid of the fractions because working with fractions for our brain is harder than working with integers. So what I do, in the beginning, between the denominators that appear, I try to find the least common multiple or the denominator. What is that? 12. So instead of starting the problem and working with fractions, I multiply everything by 12 to get rid of the fractions. So I will write it down, but you really don't need to do it. You can do it in your head. So what I do, I multiply by 12 the left-hand side. I also multiply by 12 the right-hand side. This is allowed, yes? Which one is that? Is rule number 3, yes? Here. If you tell me that A is equal to B, and then I am allowed to multiply it by a non-negative number. So I did that. I multiplied it by 12. Yes? Okay. What happens now? The right-hand side is simple, but do not. I have seen students do this mistake. They multiply 12 by 3, and then they try to divide by 4. If you want to do that, you are making things harder for yourself. So you divide 12 by 4 in your head. How much is left? 3. And then multiply 3 by 3, which is 9. The denominator is gone because it is 1. Okay? And then you do the same thing here in your head. So you multiply 12 here. 12 times 1/2. What is the answer? 6x. And then do this one in your head. So this 12 that you are supposed to multiply and this 3 will cancel that one. It becomes 4. But 4 will be multiplied by 2. It becomes 8. So you see that even if you can do this in your head, it is much better. So what you do is to just take this equation and write it in this form. Which one is easier to work with, this one or that one? Of course, this one, because it involves integers. And then you start solving it as before. What is the meaning as before? You move this 8 to the right-hand side, but you write it as minus 8. And then this becomes 6x equals to 1. So x becomes, by dividing by 6, is 1 over 6. So I intentionally solved the problem in 2 or 3 different ways. I want you to see which one is better. But you need to trust me. Getting rid of fractions early at the earlier stages are much efficient, better, but easier for us to work. Okay, so let me give you some examples of this type. that we know how to solve the equations with fractions, because there is nothing very deep here, yes? You just multiply, move things around, and then divide at the end to find your y. But what happens if I have fractions involved? Yes? For example, let me just write another one here for you. Okay, so I give you this x over 2 plus x over 3 is equal to 10. Okay, let me solve this one for you again myself. I want to solve it intentionally in two ways. I want you to see at least both of them. If I ask you to solve this and you do not want to get rid of fractions, as I told you, what you need to know, because these unknowns are on the left-hand side, you have to add them. If I ask you 2x plus 3x, you immediately answer the question, what is that? 5x. How do you find it in principle? In principle, you say that x is x, 2 is here, 3 is here. In my head, I add 2 to 3, it becomes 5, and I put it here. Yes? But it was so simple for you, you just forego this intermediate step and just suddenly write this. But for this case, first of all, I want you to understand what is the meaning of x over 2. I hope that everyone sees that x over 2 is the same as 1 over 2 times x. So if you don't really understand, please let me know, because every now and then I get the questions, people are confused about this. So you know that x divided by 2 is the same thing if I multiply x by 1/2. Yes? Is that clear?
Yeah.
Okay, so what is another name for x over 3? 1/3 of x. And if I ask you what is x over 2 plus x over 3, you cannot answer the question so fast, but you have to write the intermediate step in this case. So if I ask you what is the answer to this, you would say this is 1/2 plus 1/3 x is equal to 10. So coming from this step to this step is clear, okay? But then you have to work with fractions. I'm not saying it is so hard. It's not that hard actually at all. But working with fractions is not that simple as working with integers. But if you want to pay the price, no problems. You can continue and solve the problem correctly. So 1 over 2, you have to rescale it. So you just write 6 and 6. And here you have 3 and here you have 2. X is equal to 10. I want you to see what are the problems. And then if you add these two numbers, it becomes 5 over 6 times x is equal to 10. And then I want to get rid of x. So you have to divide by 5 over 6 to get rid of this coefficient. You see, all the time you have to work with fractions. 5 over 6 times 5 over 6 times 5 over 6 is 1x. And then here, what should I do? Do you remember 10 divided by 5 over 6? How should I act? I just write 10 times 6 over 5. 5 by 10 2 times, it becomes 12. So the answer is actually 12. So I want you to see it is really possible. But the best way to solve this equation is probably not this method, is to get rid of the fractions as soon as possible by multiplying by the smallest number possible. So what is the common denominator between 2 and 3? So that is 6. So you just multiply by 6 and you really can do it in your head. Okay, if I multiply the first one by 6, what will happen? The 6 that I am multiplying and these 2 in the denominator simplify, and then what is the answer? 3x. So you see, when you multiply by 6x, you can just simply write 3x. And then you have plus. Okay, do the next step in your head. What's the answer? 2x. Yes, is that understandable for everyone? But when you multiply the left-hand side by 6, you have to multiply the right-hand side by 6 as well if you want to keep the equality, which is 60. And I hope that you agree that immediately in one step, you get rid of all fractions. So from now on, instead of working with fractions all the time, you just work with integers, which is much easier. So if I ask you what is 3x plus 5, 2x, the question is now very simple. Because 5x is equal to 60, and you divide by 5. But 60 divided by 5 is 12. So the answer that you got is 12. So I hope that you see that this method works. It is nothing wrong. If you write this in the exam and reach to this one, you get the full mark. But I want you to understand that sometimes it is easier. It's important to learn things, to do things more efficiently. And this is one of those things you need to learn. So you learned about fractions, how equations involving fractions. Okay, so let us solve some more interesting ones. Okay, so let me give you this equation. This is a little bit harder. So x minus 2 over 8 plus x plus, over 3, sorry, plus x plus 1 over 8 is equal to 5 over 6. Okay, see, what is happening here? I have my unknown, but the unknown appears with something else in the numerator. The same thing here, but I want to find x. As I told you before, you might start working with fractions all the time, but it is not efficient at all. So first of all, get rid of all fractions. Let me write all these steps here for you. But you need to find the appropriate number. What is the appropriate number? You first of all see how many denominators are involved. There are 3 denominators involved. And then you need to ask, what is the smallest number that is simultaneously divisible by these 3 numbers? And that is the least common multiple, not 4, no, that number is supposed to be divisible by them. So I told you before, that is called least common multiple. So what's that number? 24. We cannot find a smaller than 24. So 24 is divisible by 3, it's divisible by 8, and it is divisible by 6. No other number smaller than 24 has this property. Yes, so you need to multiply everything by 24. The proper way of writing is this. You multiply the left-hand side by 24, which is x minus 2 over 3 plus x plus 1 over 8. And then you multiply the right-hand side by 24 as well. The right-hand side is simple, but do it in your head. Don't do this. Some students try to multiply this and then divide. It is possible, not wrong at all. It's not efficient. What is the efficient way to do it? Simplify 6 and 24 in your head. What is that? 4 times. And you multiply 4 by 5. It is 20. On the right-hand side, you do the same thing. So if you don't mind, let me write all the details here. I don't expect you to write all of them in the exam. You can do some of these things faster. So I took 24 and I multiplied by the first term, plus I take 24 and multiply it by the second term. Something that I want to make sure that you really understand. Here 3 by 3 1 times, 24 by 3 8 times. This is a second mistake I have seen students make. They write 8x minus 2. Okay, so they got this 8, they multiplied just here. But this 8 is supposed to be multiplied to the whole numerator. The whole numerator is x minus 2. Yes? That is different. Again, let me repeat it here. 8 to 8 1 times, 24 to 8 3 times. But is it right to write 3x plus 1? No. This x plus 1 should be in pair of brackets, even though pair of brackets was not there. But now you have to add it yourself. Now it becomes 20. The rest of it hopefully is now simple for you. So you just multiply, so it becomes 8x minus 16 plus 3x plus 3 is equal to 20. So what happens? This 8x plus 3x becomes 11x minus 16 plus 3 is minus 13, and it is equal to 20. The next step is my strategy is to make x alone. So I move 13 to the other side. This becomes 11x is equal to 20 plus 13. Yes? And if you don't mind, let me just write the rest of it here. Okay, so what happens? 11x is equal to what? 33. And then x is equal to 33 divided by 11. So x becomes 3. Again, what is the meaning of 3? It means that if I am patient and replace these x's with 3 and calculate the left-hand side, it becomes 5 over 6. Is there any other number with that property? The answer is no. Yes? To make sure that you understand this, I want to give you an example. Wait for you to solve it for me, okay? Okay, the question is this. I want you to solve this. I changed the name of the variable to get used to this. So 3 times t minus 1 over 5 minus t minus 4 over 3 is equal to 1. Okay, so I give you a little bit of time so that you can work on this problem yourself. When you got the answer, you can just tell it to me, of course, and you have to wait for me to solve it as well to see if it is right or wrong. Do you have your answer? Yes?
No.
Wrong?
You forgot to multiply the right side by 15.
No, don't do it fast. The first few examples, you have to do it patiently and precisely. After that, you learn how to do it fast.
T is minus 0.5.
Yes. That's correct. Thank you.
Wait, it's 9.5.
Okay, so let me see why some of you made mistakes. I want to describe it again once more from scratch. This is an equation. You see fractions are involved. The most efficient way is to get rid of these fractions as soon as possible. So, how many numbers you see in the denominator? Only 2. Here we had 3 of them, okay? But here we have only 2 of them. So what should I do? I need to find the least common multiple of all the denominators, which in this case is how much? 15. So let me write properly, because if that's a descriptive question, you need to write property as well. So I multiply the left-hand side, what it is this guy, by 15. But I am not allowed just to multiply 15 on the left. I have to multiply the right-hand side by 15 as well. The right-hand side is very, very simple, so let us cheat a little bit, write the right-hand side first. But now tell me, I don't want you to really write this down because it is very time-consuming. You can do a lot of things in your head. You need to multiply 15 in. What happens? Don't multiply 15 in the numerator, even though it is not wrong. It is correct, but it is not efficient. So when you multiply 15 and 5, simplify it in your head. What's the answer? 3. And then multiply 3, not just with the first one, with the whole numerator. Yes? And then do the same thing for the next one. Again in your head. First of all, the sign is negative. But 15 times that, what happens? This 3 in the denominator will cancel some part of it. 5 is left. And then you multiply 5, not only by the first one, by the whole expression. And then this is just the normal problem left for you. Make sure that you are not making any mistakes. Just multiply. It's very simple now. It's 9t minus 3. And then you multiply minus 5 in. It's minus 5t plus 20. Yes? We had this in algebra. I mentioned a lot of times. Do you remember? So it's equal to 15. Your 9t minus 5t is just 4t. Minus 3 plus 20 is 17. And on the right hand side, I have 15. And then you need to move 17 to the right. So this becomes 15 minus 17. This becomes 40 is equal to minus 2. And then I want to make t alone. So here I have to divide by 4. So t becomes minus 2 over 4. That's the correct answer. But I always prefer to work with fractions, not decimals. So I will keep it like this. In this case, if you say minus 0.5, that's 100% correct. But if the answer is minus 1/3, and you tell me it's minus 0.33, you will lose some points. Because here you have to give me the exact value. This is not the exact value of this. This is an approximation of this. This is why I'm saying try to learn to work with fractions at the very end. Don't go back to decimal points. Okay, because some of you made mistakes, I have to give you another example. Wait for you again, okay? Okay, so it is similar to this one. It is a little bit harder because it involves 3 fractions. So make sure that you are not making mistakes. And I don't have the final solution. Whenever you are ready, you just tell me your final solution. I register it under your name, see which one of you have done it right. Yes? Yes, you can just tell it.
X is minus 23.
Yeah, minus?
23.
May you repeat?
Minus 23.
33?
23.
23. This one, yes? Okay, you can continue with this one so that I can give time to others to think about. Don't be in hurry, by the way. If one of you do it fast, it doesn't mean you have to do it fast as well. You have to do it precisely first. I want 100% correct answer because this problem is not hard that you cannot solve it. Yes?
X is equal to 9.
9. Well, for that equation. So there are, you see, I want you to do it precisely. So x equals to 9. Not both of them can be correct simultaneously. Okay, let us see which one, if any, is correct. Others, please. 9? Okay. What's yours then? 9? Okay. What is yours? Okay, so it seems that 9 is correct. Okay, so you did it very fast. Be careful. You have to do it in a correct way. Okay, so let us just do it together. And if you are completely sure about the solution, don't waste your time listening to me. Go to the next one, okay? But I will describe this for those students who actually didn't understand. Okay, what I do, I see that I have equation with 3 denominators. What is the best choice here for multiplying everything by? 12. 12, you might say 24, but 24 will work, but makes life harder for you. 12 is the best choice here. So you multiply by 12. So you write the first step. I multiply the left-hand side by 12. To keep the equality, I have to do the same thing with the right-hand side. So this is the first step. But this step, I really prefer you to do it in your heads, unless you really want to do it step by step. If I want to do it myself, I multiply 12 here, but I do not multiply 12 in the numerator. Let me repeat, even though it is correct, but it is not efficient. So what you do, you simplify 12 in your head by 4. What is the answer? 3. And then you multiply 3, not just by the first term, by the whole combination in the numerator. And then you have a negative sign, and then repeat the process. 12 and 6 are simplified, 2 is left. So you multiply 2 in the whole numerator. And then here you have 12 and 3 simplified, 4 is left, but 4 times the whole numerator. And then when it reaches to this step, I think it's not hard at all. You just need to be careful. So you multiply 3x plus 9, you multiply minus 2. Okay, it's minus 2x. If you write minus 10, that is wrong. You have to write positive 10. Yes? And on the right-hand side, you have 4x negative 8. 3x minus 2x is just simply x. 9 plus 10 is 19. And then you have 4x minus 8. Okay, now this is a little bit different from the previous problem because x appears on the left and on the right. But I want to move all of them to the left. So x is already here. I move 4x to the left. It becomes minus 4x. Minus 8 is already there. I move 19 to the other side. It becomes minus 19. But x minus 4x is minus 3x. Minus 8 minus 9 is how much? Minus 27. And there is one step left. To make x alone, I divide by minus 3. The left-hand side becomes x. Minus 27 divided by minus 3 is positive 9. So that answer is completely correct. Thank you. So it means that you learned everything because you do not have harder problems like this. The problems harder than this in your book. Okay, so I want to wait for you to see how many of you answered the other one. So
I have something to say about the one you just did.
yes,
There where you move 4x to the left.
yes,
For those who think that it's more comfortable to have the unknown on the left,
yes.
You can just flip them. So 4x minus 8 will be on the left, x plus 19 will be on the right, and it's still since they're still equal to each other, it'll still work.
Yes.
But that way it'll be the unknown will continue to be positive, and even the known will continue to be positive.
Yeah, these are subjective matters. As soon as you do, as far as you do them consistently, that's okay.
I have a solution for the other one. It might be wrong.
Okay, what's the answer?
I got x equals 53.
53. Okay, so let me just reserve it. Any other opinions?
I don't see that.
Okay, I can wait a little bit more because I want to make sure that you really know what's going on.
Okay, I'll do it. You took 30 as the common multiple, correct?
This one, 4x plus 2 by 5.
Why did you take 30 as the common
Oh, no, it's not. I accidentally wrote the question wrong.
Okay, so
Oh wait, no, I didn't. I read the other. No, I wrote it right.
I looked at the top.
yes, 53. Okay, so might be it is not a coincidence. So, but I want to wait for others. Because if, in principle, everyone should be able to get the correct answer, yes? 53? Okay. Okay, good. So this lesson is not hard at all. So this, you need to learn how to work with it. Of course, the topic of equations is a very interesting topic, might be sometimes hard, but not these questions. Okay, so if you know, let me just solve that and then we can stop here. So what is, you can tell me what to do. What is the number that you chose to multiply? 30. 30 is the smallest possible number with the property that these are divisible by. So I hope that you agree this method is very efficient rather than working with fractions. So you multiply by 30. So let me write this step. 30 multiplied by the left-hand side, which is 4x plus 3, divided by 5, minus 2x minus 3 divided by 3 is equal to 30 multiplied by x minus 1 divided by 6. The right-hand side, the left-hand side means you need to multiply this here in your head. Simplify. Let me just emphasize again, do not multiply in the numerator even though it is true. Correct. So 30 and 5 are simplified, 6 is left. So 6 multiplied in the whole, you have to multiply it by the whole numerator. And 30 and 3 are simplified, 10 is left. Of course, the sign is negative, and this 10 should be multiplied by this. On the right-hand side, this and that are simplified, 5 is left, 5 should be multiplied by x minus 1. Yes? And then you start simplifying things. So this becomes 24x plus 18 minus 20x, and what is next? Plus 30. So make sure that you don't get confused with the minus signs. And on the right hand side you have 5x minus 5. Do some simplifications. So it is 4x, 18, 48, 5x minus 5. I move 5x to the left. So this becomes 4x minus 5x. Minus 5 is already there. I move this to the other side. But then it becomes minus x is equal to minus 53. But we are looking for x. So what is x? X is 53. So the answer that you provided is completely correct. So this shows that you actually learned this lesson very good. Any questions? Okay. So I really recommend you to go back to work so you know that you have only one session. On Monday I will not teach. I will let you to ask any other questions that you have. On Tuesday we will have the exam. Any questions for this lesson?
Will equations be in the exam?
No. This would be the topic of the next exam. Okay, thank you very much.